Okay, number 57 is a tough one. We're being asked to take the derivative of y, which is the square root of a quotient. So as I've said before, and I'll keep saying again, I don't think we're ready yet, guys. Maybe we will be at some point, maybe not, to take the derivatives of square roots. I think it would help us to rewrite this now as z plus 1 over z minus 1, all of which is being taken to the 1/2 power. So now we can take the derivative of y with respect to z first by using the power rule. We've got something being taken to the 1/2 power. So that derivative is going to be 1/2 times the exact same base, z plus 1 over z minus 1, and then drop the power by 1. Oops, that'll be a negative 1/2 for that exponent. But now the fun part, times the derivative within. So we need to multiply by the derivative of the base of this exponent, which is right here. Well, that base is a quotient. That means that that derivative within is going to require the quotient rule. So here we go. The bottom is z minus 1 multiplied by the derivative of the top. Well, the derivative of z plus 1 is just 1. So I could put a 1 there in parentheses if I wanted to, but that doesn't really accomplish much. I'll just leave it there. That's bottom times derivative of the top minus the top, which is z plus 1. And guys, there's a pitfall right there. As soon as you're subtracting a binomial, you want to make sure you put parentheses around that. So that was minus the top and then times the derivative of the bottom, which is also 1. So we can ignore that. All over the bottom, z minus 1 quantity squared. Okay, so that's where we're at right now. Let's see what we can do to simplify this whole mess. This could get interesting. Let's take a look at what we've got. All right, guys, the 1/2 is going to give me a 2 on the bottom and potentially a 1 up on the top. I'm not sure I need that yet, but I'm going to put it there because I'm pretty sure this line that I'm writing right now is not going to be my final answer. Boy, I'm tempted to do something weird right here. The way that this term right here is written, it's something to the negative 1/2 power. I'm tempted to make that a square root on the bottom of z plus 1 over z minus 1, but now I've just made this a complex fraction. So what I actually want to do here is remind you guys of a fundamental idea here, that anytime you have a fraction like a over b being raised to a power, that power applies to your numerator and it applies to your denominator kind of separately. And I'm going to kind of do that same thing right here. That is going to be then a z plus 1 by itself to the negative 1/2 power, which means I'm going to make it a square root of z plus 1 on the bottom of that fraction. And then what was the denominator right there, this now becomes a z minus 1 to the negative 1/2 power in the denominator. The negative power moves it up to the numerator, and that's now z minus 1, or the square root of it right there. All right, that was kind of a weird one. Okay, what happens next? As we take a look then at what's happening in the numerator, where we did the quotient rule, that's going to be a minus z and a minus 1. Well, plus z and minus z are going to cancel each other out, but negative 1 times plus another negative 1, is going to give us a negative 2. And that, you got to be careful, guys, is actually being multiplied by everything else that we had right there. So there's your negative 2, and then down in the denominator, z minus 1 quantity squared. Okay, I can see a couple of little things that are going to happen right here. Let's take a look. Maybe this is going to be our final answer. What do I see? I see a 2 as a factor in the denominator and a 2 in the factor of the numerator. They'll cancel out, but the negative did not go away, you guys, so we got to be careful of that. There's still going to be that negative. Yeah, I'm going to make that a negative 1 up there in the numerator. You'll see why in a second. Now, in the denominator, we've got the square root of z plus 1. That didn't change at all, but I want to talk about what's happening right here, guys. What we had right there is a z minus 1 with a square root. So that's a 1/2 power on the top, and then a z minus 1 quantity squared on the bottom. Those two can be combined. You've got to figure out where it's going to go first, top or bottom. Well, the bottom exponent in the denominator is larger than that of the numerator, so the z minus 1 factor is going to end up in the denominator, and you always then just take the larger exponent minus the smaller one. 2 minus 1 is going to give us 3/2 right there. And boy, that's a weird looking answer right there. I don't love the format right there that I have that combines a radical with this expression right here that has fractional exponents, but it's mathematically correct. I'm confident in saying that. I'm looking at the solutions manual right now, and they've got it written exactly the way we have it right here. -1 on top, a square root of z plus 1 on the bottom, followed by a z minus 1 to the 3/2. So that is our answer there, everybody, for dy dz. Tricky little problem there, number 57.